Alright, this is just a real quick video on how to solve exponential functions by rewriting numbers with different bases. That's all we're doing here. There's multiple ways to solve exponential functions. This is the simplest way, and we're going to start with that. First of all, you have to know how to rewrite numbers with different bases. It sounds difficult, but really all you need to know are your squares and your cube roots. So, for instance, if I give you a number like 4, I can rewrite 4. I want to rewrite that as some number that is also equal to 4 with a different base. So if I keep the base, I can write this as 4 to the first. I want to change the base. So I'm going to write this as 2 squared. 4 is the same thing as 4 to the first, which is the same thing as 2 squared. Both of these quantities are the same. They both equal the same thing. So if I'm ever given a problem and I need to change the base, then I can do it this way. Let's look at another one. Let's say 8. How can I rewrite 8? Well, there is no square that's an 8, so I can't rewrite it as something squared. But there is another power that I can see. Hopefully you recognize this. 8 is a cube. It's a perfect cube. It is 2 cubed. So I can rewrite this as 2 cubed. So 2 to the third power is 8. I changed the base from 8 to the first, and I changed it to 2 to the third. Let's look at another one. Let's look at one that's a little bit more, has more options. Let's say 16. Right, 16, the first thing that should come to mind is 16 is a perfect square, so that's 4 squared. So I can rewrite 16 as 4 squared. But I can also rewrite 16 because it is a perfect fourth. 16 is 2 to the fourth power. Now, if you didn't notice that right off the bat, you could say, okay, well, here I have 4 squared. I can actually rewrite 4. We just did that. I can rewrite 4 squared as a base of 2. So I would change the 4 to 2 squared. That's equal to 4. But I still have this whole thing to the second power. And when we have a power to a power, we multiply. 2 times 2 is 4, so 2 to the fourth power. So that's where that comes from. And we're going to look at a couple examples, and hopefully you'll see what I'm talking about. But before we do the examples, you need to know how to change numbers and rewrite these numbers with different bases. And this is the reason why we talked about having your perfect cubes and your perfect squares memorized, just because you need to be able to work with them fluidly. So let's look at some examples. Okay, example number 1, 3x equals 9, or 3 to the x equals 9. This is kind of an obvious thing. 3 to what power equals 9? Well, I mean, that's 3 squared equals 9, so x is 2. Right off the bat, you get x equals 2. But just to show you how this works for everything, we can rewrite these bases. So 3 I can't change, it's 3 to the x. Usually you're going to rewrite to the smallest base. I can rewrite 9. 9 is 3 squared. 3 squared. And there's a property called the equality of exponents. This means that if these two bases are the same right here, then the exponents have to be equal, which makes sense, because if I say 3 to what power equals 3 to the second power, well, it's kind of obvious the only answer is 2. 3 squared is the only thing that's going to equal 3 squared. So when you have bases the same, your exponents are equal. That's the whole principle behind this. When the bases are the same, the exponents are equal. So that's what we're working towards. We're trying to get the bases the same, because when the bases are the same, the exponents are equal. So let's look at number 2. I have 5 raised to the 2x plus 3 power. And I mean, I could even put this in parentheses if you want to. 5 raised to the 2x plus 3 power equals 25. Hopefully in time you will see the relationship here. You'll quickly recognize that 5 and 25 have a special relationship. 25 is 5 squared, and that should jump out at you eventually after you do enough of these problems. So I'm going to rewrite it like that. I have 5 raised to the 2x plus 3 power equals, and I'm going to rewrite 25 as 5 squared. So now I have bases the same. That's the whole point of changing the base, to get the bases the same. So my exponents are equal. So I can actually rewrite this as 2x plus 3 equals 2. And now I just solve for x like a linear equation. So 2x equals -1, x equals -1/2. So the only time this original equation is true is when x equals 1/2. All right. So let's look at a little bit more challenging example, number 3. Here I have 2 to the x plus 7 equals 8 to the x plus 1. Again, hopefully, eventually, you recognize this relationship between 2 and 8. 2 is the lowest we can go for a base. 8 is 2 cubed. So I can rewrite this as 2 to the x plus 7 equals, not 8. 8 is 2 cubed. So all I've done is I've rewritten 8 as 2 cubed. But remember, 8 was raised to the x plus 1 power. So this whole thing, this whole 2 cubed, has to still be raised to the x plus 1 power. If not, then this isn't the same. 2 cubed is 8, and in the previous step, 8 was raised to this whole power, so the 2 cubed has to be raised to this whole power. And now we have a power to a power. So when we have a power to a power, we multiply exponents. So I can go ahead and leave this here, 2x to the x plus 7 equals, and I'm going to do this out to the side. I have 3 times the quantity x plus 1. This is just distributing. I get 3x plus 3. So this actually becomes 2 to the 3x plus 3 power. And now my bases are the same, so my exponents are equal. So x plus 7 equals 3x plus 3. Let me create a little bit of space here. Okay, so now I want to solve for x, so I'm going to subtract 2x from both sides and subtract 7 from both sides. Let me put that in a different color so you can see it. So, and subtract 7 from both sides. Oh, that should be minus 3x, not minus 2x. Simple fix. Sorry. I want to subtract 3x from both sides. There we go. All right, so I'm left with negative 2x equals -4. So divide both sides by -2, x equals 2. So the only value for x that satisfies this equation is when x equals 2, which makes sense because this is 2 to the 9th, and this is 8 to the 3rd. If you plug those numbers in your calculator, you will get the same answer. All right, so let's look at number 4. And I'm moving quickly through this because if you have questions, you can pause and rewind or go back and look over it. So number 4 is a little bit different. I can't really simplify 27 to be 9. There is no, I can't 9 to no whole number power equals 27. And I can't get 9 to look like 27. So I'm actually going to have to simplify both of these numbers to a common base. And hopefully, eventually, again, you will see the relationship between 9 and 27. They both have a 3 in common, so maybe that is the relationship. So let's try and simplify both of these to a base of 3. And this is the hardest type of problem that you will encounter whenever you have to simplify both bases to a common base. So we're going to change this 9 to 3 squared because that is what 9 equals. 3 squared equals 9. And in the previous step, the 9 was raised to 2x minus 1 power. Okay. We're going to rewrite 27 with a base of 3 also. And 3 to the 3rd power equals 27. So that's 3 to the 3rd. And add to the x power. All right, so now I'm going to distribute. I got power to a power here, so it's going to become 3. And this, I'll do this out to the side. 2 times 2x minus 1. So that's 4x minus 2. So this is 3 to the 4x minus 2 power equals, and this is just 3 to 3x. Now I have bases the same. That means I can set my exponents equal to each other. So 4x minus 2 equals 3x. If I add 2 to both sides and subtract 3x from both sides, I get x equals 2. So there's your final answer. X equals 2. These problems aren't that bad. You just have to know how to simplify bases. And make sure you apply your laws of exponents correctly. Power to a power means multiply. A lot of times that means you're going to have to distribute. So you can do that off to the side, however you want to, but just make sure you distribute correctly.